I guess to give you a better understanding of how it is being used, we have an example which we're just going to briefly cover over here that is related to, again, the tilt wing you've seen earlier. It has a secondary external / external emergency termination system. This is just for, again, overview of all of the features that are supported right now in the firmwares and softwares that we're using. All right, so just for this setup, for your own understanding, what we have is we have a ground control station or ground station desktop computer. It can be anything. It's running Windows with all of the MATLAB and Simulink tools on it. We have a HearLink controller. You can buy that. It's just off the shelf. It works perfectly. It's with its own built-in, or I guess the module that was developed for this called HearLink Air module that goes on the vehicle. In addition to that, we have a secondary telemetry pair. We're using we're using RFD 900. So one module is, again, on the vehicle. The other one is on the ground, hooked up to the second control station, which we also call I'm calling as emergency termination system, referred to also as the BRB, like Big Red Button, because that's literally what is hooked up to it, and that's the main reason for that to exist. And the basic idea is that if somebody, like if you have a requirement to have a second pilot, or not pilot, but a safety officer for any kind of in-the-field testing and monitoring, whose sole responsibility is to terminate the system if he deems anything is wrong and going out of control, that's what it does. Of course, things had to be implemented to get it all working, so there is a separate piece of software called K-Ground Control. It's running on the Raspberry Pi. This is just a touchscreen with the Raspberry Pi and the USB button connected to it. At the end of the day, all of that is handled by the K-Ground Control software, also developed by me. Same software is running on the desktop, so it's fairly convenient, I think, because you get to learn one software to do both things, and you can run it on different system architectures. All right, so the way we do this, and the way I set it up, just for you to, I guess, get a better understanding, let's start with the data flow from the vehicle. Same diagram, same everything. So the telemetry part is fairly simple. We have, again, a secondary telemetry configured by the PX4. And as you know, that's just standard functionality, and it will automatically start broadcasting Mavlink messages related to, again, telemetry, all of the states and additional data that may be important. You just have to specify that you have plugged in this telemetry module at this serial port, and it's using this baud rate, and you can select what Mavlink communication profile you use. By default, again, it still works. You can use the default, I think normal, that's what it's called. And then it will relay all of the telemetry data back to the vehicle, which is more than enough. And on this mini GCS site, we can browse all of that and use that for any kind of monitoring that we want to use. That's simple. That's fairly standard. Nothing special there. Same thing with the HearLink. We have all of the data. Specifically, again, for this presentation, we have telemetry plus Mavlink debug fluid array. I added a special Mavlink, not protocol, but Mavlink communication profile. Instead of normal, we're using that because it adds additional messages that we want to receive on the ground. And then there are separate parameters where you can enable, disable the Mavlink debug or fluid array specifically for all of these messages, because sometimes you don't need them or you want to change the streaming rate. Because this, for example, the HearLink is quite enabling in terms of this really high bandwidth, and we could stream very fast and at a really, at a high rate We can stream a lot of data at the same time. Just very convenient. For some of the other modules, like even this RD 900, you would probably not want to stream it at the same rates, and you want to maybe stream only one or two of these messages and maybe at a lot lower rate. So again, this is up to you. This is more of a just overview. Then the HereLink is essentially a Android phone with some custom firmware and configuration that supports built-in joysticks, these two joysticks over here for flying, and the built-in receiver / transmitter. There is a Wi-Fi hotspot module, so there is standard, Wi-Fi hotspot like you can make on any Android or iPhone or any other phone. You just go to settings, enable hotspot, configure the hotspot for your own settings that you want to use. Pick the name, pick the password, enable hotspot. After that, the data will be available automatically. The HereLink is configured to make all of the data shareable and available on its local network that it's connected to. The simplest way is to use the Wi-Fi hotspot and connect your ground station to that Wi-Fi hotspot, so you can retrieve all of the data from it using, for example, QGround Control, Mission Planner, or KGround Control, or any other app that you may think of. This is fairly standard. The only catch is, again, since it's all on Wi-Fi hotspot, you just have to be close. Your ground station has to be close to your pilot holding the HereLink transmitter or controller. All right, so the data the data flow to the vehicle. Same thing. Let's start with the mini GCS. It's basically has a support for this single button. Once you press on that, it sends a remote command. It's a Mavlink command, understood by standard PX4. So it's a stock PX4 command for disarming or arming the vehicle. For this purposes, we configured it to have it be solidly binded to disarm. So whenever the button is pressed, we send a Mavlink command. Over the telemetry, it's interpreted by the PX4 firmware, and it sends internally a disarm request. If you are overriding that request from the firmware, or you're not using that, of course it will not work, because this is purely talking with the PX4 firmware, and the input-output framework was configured to use the internal PX4 states and all of the internal modules. Basically reintegrates your control system with the PX4 as long as you use those inputs and outputs and don't start adding some new messages or try to get data directly from, for example, your ground control stations into Simulink by passing PX4, because then the PX4 doesn't know what's happening. So that was basically the intent for that. All right, so then on the, primary ground control station, what we have is we have multiple things running, which we'll cover later, but basically there are some couple of joysticks connected, similar to HereLink. So those are being sent, as well as all of the QGround control commands are also being sent. All of that is being sent to localhost, meaning that they're all just internally communicated within the desktop for any other app to grab that. That's not going to the vehicle. What makes it all go to the vehicle is this KGround control, which essentially grabs all of the data from the local host and forwards it all over the Wi-Fi connection to the HereLink. This is not super relevant, but as far as I remember, I think this is actually a mistake. We are sending most of the time Simulink inbound control message from, well, actually, this is not a mistake. Hold on. All right. So if you were just to fly and ignore HereLink altogether, you can send just in Simulink inbound and configure the parameters appropriately. When you want to use both HereLink joysticks and K-ground control, what is being sent here, and this is just overly simple, but we are sending Simulink inbound control message. And basically what I mean by that is, again, like we're still sending just Mavlink float array, but inbound control refers to a specific ID, right, of the debug float. Of the debug array, there is a specific ID that we're filling in, so the rest of the system understands that. But yes, all right, so, but it's not relevant. Again, the same thing happens. It can be Simulink inbound control or any other message corresponding to the framework. HereLink just blindly forwards that. It doesn't do anything to that. It simply forwards that data to the vehicle, just like it forwards all of the communication from the Q-ground control if that's being sent. It also generates, so HereLink will generate its own commands. You can run Q-ground control in it, that will send its own commands, in addition to these over here, so that can get confusing. Don't forget that Q-ground control by default assumes the same address, or I guess host or whatever. So these two, Q-ground control running on these two, will by default be interpreted as one Q-ground control on the other end, so it can raise some issues, just to be aware of. So sometimes it's useful to disable Q-ground control here if you're not using it. Also, of course, HereLink will generate its own RC commands and send those over. So there are joystick commands that are being interpreted, sent over, and they appear on the other side just like any other RC. All right, so just as a quick summary of the exact connections that we have for all of these pieces, let's take a look at this slide over here. On the left, you see GCS desktop communication summary. Then you have the mini GCS BRB, or again, this emergency termination system. We have PXHawk and HereLink controller. So let's start from, I guess, the hardest one. So the GCS, the desktop, is probably the most cluttered. You have, I split the two into local and external connections just for everyone's understanding. Local, in this case, I refer to everything again locally, communicating on within the same desktop. So there's no data going out of the computer or into the computer in these connections. We have K-ground control, which is essentially our communication glue that does all of the relaying and bridging or whatever we can think of. It has three UDP ports / connections, where two of them are for the Simulink, for all of the receiving and for all of the data that is being received from Simulink and the data that is being sent to the Simulink. Then there is a single port for Q-ground control for reading and writing to it, which basically, again, is if we want to run QGC, we would just have to configure it to talk with the K-ground control, which, again, the settings I'll show later, they work out of the box, so this would be automatic. The Q-ground control would just automatically connect without any issue. The Simulink, though, it has to be, again, the model that is included as the example, it has the UDP communication ports for reading and writing set up appropriately to match these two in the K-ground control. In addition, you can, of course, have some other stuff in the Simulink. For example, you can have some overlay like a cockpit display or whatever you want in terms of showing all of the data and visualizing it real time as it's being received. Again, it's internal stuff, doesn't really make a huge difference, so I'm here just showing it as an example. External connections. So this is the important part, where this is where we get the data to or from the ground station itself, and it's done all through K-ground control. There's a single communication port being used for all of the talking between the ground station and HearLink. So this radio over here, and it's all happening through its own internal hotspot / Wi-Fi. Simulink can also have, as I mentioned, which it does in this case, connected joysticks or any other peripheral devices. It can be done by just as simple as a plug-in USB joystick, or maybe something more complicated. It doesn't really make a huge difference, but this is like additional thing that can be like plugged into and managed on the Simulink side. The mini GCS is more or less the same, except just simpler. We have at the back of this, we have a Raspberry Pi running just Raspbian and AVS standard one, and it runs a compatible version of K-ground control. Again, the same app that runs on the desktop computer is also running over here, and it's doing all of the low-level stuff needed for the communication, which in this case is, again, it's the same app, so you can do the same things on both of these, and they're interchangeable. For the ground station, or this mini ground station, what we needed is we want to have an emergency termination button that somebody like a second pilot or safety officer or whatever you call it can have and press it in case of any emergency, or use this as a backup in case the primary communication fails and all of the other automatic termination system fail. It is just wired up. It's a simple USB device. It's actually just emulating a keyboard enter key. So it's very simple to implement, and the K-ground control can be directly configured to use that and send it as a disarm signal. So there are only two real serial connections in this case. It's the one that is for the BRB, the USB connection, and the second one would be the RFD 900 module, the ground part of the telemetry pair that we have talked already. Alright, the PX4 that goes on board, for communication, it has to have the following connections. Like, this is the external setup. We have 3 connections in total, 2 coming from the HearLink Air module. It has a separate S-bus output for all of the commands, manual pilot commands generated by the HearLink. So this is separate, and is coming in as the S-bus output. Then all of this stuff that we want to relay to, or I guess send to the vehicle, like commands that we send from the GCS, or for example, data that we get from the Simulink that we are forwarding through K-ground control, we also want to send to the vehicle. All of that is configured on a telemetry port or telemetry connection of the PX4. Can be primary, can be secondary, up to you, doesn't matter. Obviously configure that for the correct baud rate and the correct telemetry Mavlink profile of your own choosing. That's not going to affect the reception of the data. It's only going to affect what you're seeing being sent back. Same thing for the secondary telemetry, which is in our case RFD module. And the last one is the HearLink controller. All of this is pretty much automatic, but basically out of the box, you would just have to like bind the HearLink Air. I'm gonna make a separate video on just like what do you do and walk through all of the apps over there. But basically, you have the HearLink Air module that's already just connected to it, pretty much out of the box, and then you would just have to enable Wi-Fi hotspot for data sharing. There's no extra app or whatever you need to run to make it all work. Alright, so let's talk a little bit more about this K-ground control thing that I mentioned a couple of times. So this is like a custom app that I wrote for my own research purposes, and it's sort of combining a whole bunch of features and things that I developed over the time, and introduces that as a nice UI, just wrapper that is more convenient for other people to use, and also honestly for me too. It's more of a, not an add-on, but it's more of a trying to fill in the gaps of features that I needed from the Q ground control that are not available there. So it's more or less intended to be used as a substitute, but it's a standalone app, so you can technically use that without Q ground control. It's just some of the features that are supported in the Q ground control I didn't want to spend too much time re-implementing in this app, so it's more focusing on providing new capability. You can read more about it. There's a separate GitHub page for that. Get all of the installation tutorials, whatever you want. So that's a separate item. For this purposes, just to configure it the way I mentioned on the previous one, we have a there's a communication panel setup tab, whatever we can call it. We can add separate connections, sort of similar to how it can be done in Q ground control. Just obviously it looks totally different. And it has some other flavor to it. It's not as automatic. I need it to be more explicit and just manual. But you basically add 4 connections in total, as I mentioned, on the main ground control or desktop computer side. You run the KGC, go and click on Add button and configure these 4 connections. Basically, the bottom point there is have to provide the correct IP address, correct port for host and local, or I guess for your target that you're communicating, and then all of the local information. So this is already configured, that you see here, that it's going to match the same stuff that is already pushed to the GitHub page, the Simulink model. So if you configure it the same way as it is here, shouldn't run into any problems. The only part here, you may not need to drop your update rate to 500 Hertz over here. I don't actually remember why this was done. I think I just forgot to type in 1000. 500 probably was a default, so that's not like mandatory or whatever, but just in case, I copied the exact configuration we were using. Don't forget to do relaying. So this relay tab over here, you would have to click on this relay, not emit heartbeat, but like relay. This is a separate button, and you see you need to make sure that all of these separate connections are configured to relay data to the correct ports. Just like here, you see HearLink, all of the data coming from the HearLink radio will be relayed to the port labeled QGC and the Simulink TX port. Similarly, for example, Simulink RX port, whatever we read from that port, we're going to relay that to the HearLink. So that's available to the HearLink. If we don't do this relaying, obviously data won't be available on other ports. Same thing for everything else.